Good morning, boys and girls. Tomorrow is our big old exam. It will be on Google Forms. It will be almost all multiple choice, maybe a couple fill in the blank. I just think that's the easiest for everybody, depending on the devices that they have. But today we're going to look at your Jeopardy review over waves. So your exam tomorrow will be heavier in concepts 1 and 2 that we went over while we were in class together, and will not be as heavy in concept 3. And my glasses keep reflecting, and that's aggravating. So we're going to do this blurry. So remember, look over concepts 1 and 2 the most before this test. Concept 3, do your best on it. Take your time. Use your notes. Yes, Mr. Lacey said, use your notes. Not like you weren't going to do that anyway. All right, let's go on and look at your Jeopardy review on waves. So click. All right, the names for the highest and lowest points on a transverse wave. Remember, transverse waves, they do this. Woo. Names for the highest and lowest points, a couple different waves, peaks and valleys, crests and troughs. Crests and troughs, very good. Time it takes for one wave to pass through a given point. So time it takes for one wave, not the number of waves. One wave is the period of the wave, how long it takes a single wave to occur. This is the other one, the number of waves that pass a given point in 1 second. That is the frequency. Frequency, how many waves in a second, period, the time it takes for one wave to happen. Remember, they are inverses of each other. All right, moving on. The distance from the crest of one wave to the crest of another. I'm measuring the length of a wave. The length of a wave. It's a, you guessed it, wavelength. Measure of a wave's energy. Measure of a wave's energy. Think about it, how loud a wave is. If we're talking about a compression wave, how you're squishing them together, that is a measure of their amplitude, how much energy you're squishing in there. I would also take frequency, because the higher energy a wave has, the higher frequency it has too. Those both increase energy. All right, next question. This happens when two or more waves continually overlap. This is like when you're driving down the road and you're hearing two radio stations at the same time. That is an example of interference. This occurs more to sound waves on carpeted floor than tile floor. The reason your theaters and amphitheaters and all those things have carpet on the floors and the walls is to absorb the sound. So sound waves do get absorbed more on carpet than they do on tile. That's why your bathrooms are all echoey. This is an example of a sound wave reflection. Oh, we just said what it is. That's an echo. It echoes more on tile than it does on carpet. Next question. As wavelength decreases, what happens to frequency? As wavelength decreases, the waves are getting squished together. It takes more energy to squish these waves together. Increase in energy is an increase in frequency. So as wavelength goes down, frequency goes up. They are indirectly related. The type of wave that moves perpendicular to the direction of wave travel. The wave travels this way and it vibrates up and down as it goes. That is our old friend, the transverse wave. Awesome. Moving on, electromagnetic waves travel fastest in, remember, electromagnetic waves, they travel through outer space and they actually slow down when they hit things like water and glass and air. So they travel fastest in a vacuum, which is outer space. A bird just flew into my window. Wow. List 3 uses for radio waves. There is a bunch of uses of radio waves, from car radios, cell phones, walkie-talkies, MRIs, Wi-Fi. Those are all examples. They fall in that category of radio waves. Write out the electromagnetic spectrum in order and label the trends of wavelength, frequency, and energy. Okay, if you're going from low energy to high energy, as the energy goes up, the frequency is going to go up, the wavelength is going to go down. So we have radio that's on the lowest. We have gamma that is the highest. We have visible light in the middle, but radio, microwave, infrared. If you remember that the colors of the rainbow are red, orange, yellow, green, blue, indigo, and violet. Infra means below. So the reason this spectrum is called infrared, because it's below red, This is violet, and ultra means above, so ultraviolet is above violet. Creative names. Ultraviolet, X-ray, gamma rays. So low energy on the left, high energy on the right, big wavelengths, little wavelengths, low frequency, high frequency. All right, moving on. Is sound a mechanical wave or an electromagnetic wave? Sound cannot travel in a vacuum, therefore it is a mechanical wave. Good deal. There are two types of mechanical waves. Which type is a sound wave? There are two types of mechanical waves. It is a longitudinal wave. The other one is called a transverse wave. Again, sound waves are longitudinal. They are compression waves. They vibrate the same direction they travel. Transverse waves, they do this whole thing where they vibrate perpendicular to the way they travel. As frequency of a sound increases, the pitch of the sound. Okay, frequency goes up, the pitch goes up. We saw that on our guitar. We changed the frequency, we changed the pitch. They are directly related. As loudness of a sound increases, the amplitude of the wave. Amplitude is the measure from the rest position to a peak or from the rest position to a valley. And as a wave gets louder, that amplitude keeps getting bigger. It increases. Which of the following sounds will have the shortest wavelength? Okay, if it's going to have the shortest wavelength, it needs to have the biggest frequency. So I'm looking for the number with the biggest frequency. It should be B, high frequency, low wavelength. These have lower frequencies. Awesome. Yay, we were right. A 5-meter wave is made by dropping a ball in water, has a frequency of 2 hertz. Find the speed of the wave. Okay, let's learn how to annotate on here. So, velocity is frequency times lambda, which means wavelength. Imagine that looks like a lambda. I'm not good drawing with a mouse. So, if I want to find the velocity, that's going to be equal to the frequency, which is 2 hertz, 2 times the wavelength, a 5-meter wave, times 5. That means the velocity is going to be equal to 10 meters. That's a second. Let's check and see if it's right. Let's go back to the mouse so we can check it. I don't know what I'm doing. Yay, 10 meters a second. Good deal. We got it. A tuning fork has a frequency of 200 hertz. Find the frequency, or I'm sorry, find its period. So if we remember back from our formula, we know that the period T is equal to 1 divided by the frequency, which means that the period of this wave is equal to 1 divided by 200. So that should be 0.005. Let's check that. Let's check it. Hey, 0.005 seconds. Awesome. Wicked. Let's move right along. Back to the mouse. All right. If an ocean wave is 5 meters long and it passes a buoy at a rate of 8 waves every 2 seconds, what is the speed and the period of the wave? Okay. So let's start with, let's see. We know that it passes a buoy at rate 8 waves every 2 seconds. Okay. Frequency is not the amount of waves that happen in 2 seconds. It's the amount of waves that happen in 1 second. So if there are 8 waves every 2 seconds, that means my frequency will be the number of waves in 1 second, which is going to be 4 hertz. All right. We know the wavelength is equal to 5 meters because of this feller. All right, so if I want to know the speed, it's going to be frequency times wavelength. So the velocity is going to be equal to frequency 4 times 5, the wavelength. Imagine that looks like a 5. That means my velocity is going to be 20 meters a second. And it wants to know the period. The period is going to be 1 divided by the frequency. The frequency is 4 hertz. That means the period should be equal to 0.25 seconds. Let's check it, make sure it's right. Yeah, speed is 20 meters a second, period is 0.25 seconds. Wicked. All right. Yeah. All right, explain how rainbow forms. Okay, so we have white light. It comes into a prism, and that white light gets refracted. Refraction means that light is coming in, it hits a new substance, and it changes its direction. It bends, and it also changes its speeds. And since different colored light has different speeds, because they are getting bent different amounts through the prism, it's going to split that white light, which is the mixture of all light, up into all its colors: red, orange, yellow, green, blue, indigo, and violet. Light waves enter a prism and slow down due to the change of medium. Yep. This causes the waves to bend, which is refract. Different colors of light are different wavelengths. They travel at different speeds, and then we get all the colors out. Awesome. Pink Floyd. Woot woot. All right, let's go. Is that it? That was Final Jeopardy. Boys and girls, expect questions just like this. Again, use your notes on the test. You will get at least one shot. It is mostly multiple choice. There is some fill out the blank, and this will go on the fourth 9 weeks. This will not go on the third 9 weeks, since the third 9 weeks is already over, and I will just be putting in makeup work. So, boys and girls, send me a question on Google Classroom or via email if you have any questions. Let me know. Love you all. Miss you all. Hopefully, I get to see you very, very soon. So let me know if you need anything.